Alright, so last time we talked about exponential functions, so this time we get to talk about logarithms or logarithmic functions. Anybody have any web sign problems or anything like that we need to look at? Okay. All right. Let's see. So we have a logarithmic function. We're going to have log written out, okay? And then usually on the logarithm you'll have a little subscript number down there. Okay, so here I've got a lowercase b down there, and then we'll have an x, and sometimes you'll see them written like this as well. You can write them with or without the parentheses after the log. Okay. And this number b is the base. And that is related, last time when we talked about exponentials, it's related to the base of an exponential function. Okay. And then our x, or whatever is inside of the logarithm, what we'll call an argument. Okay. Still around. Okay. That's what they look like. What it represents, okay, is really just another way of writing down something about an exponent. Okay. So before, last time, we would have something like this, b to the x power. Okay, so let's say we had that as an equation. So we've got some number to the x power equals n. Okay. We could write that in logarithm form. Okay. We could say the log with the base of b of n equal x. Okay, so these two equations say the same thing. Okay. This one is in exponential form because we're writing it as an exponent. The other one is in logarithm form because we're writing it as a logarithm. Okay. So as a function, if we have f of x equals log base b of x, okay, if we're like trying to figure out what number we would get as our answer, if we're trying to evaluate it at some functional value. Okay, so let's do this one. Well, let's do x. And then we want to find like f of 8. Okay. That would mean we want log base 2 to 8. And we can figure that number out. Okay. So what this is saying is that if we take the base, this number, okay, and raise it to some power, we'll get the number that's on the inside, the argument. So this says if we raise 2 to some power, we're going to get 8. So 2 to what power would give us 8? And then how many times we have to multiply 2 by itself? So 2 times 2 would be 4, and then 4 times 2 would be 8. So 2 times 2 times 2 is 8. So log base 2 of 8 is 3. That's saying that 2 to the third power, 2 times itself 3 times, would give us 8. Okay. So the equivalent way we could write it down in this other form over here. We could write that same equation down. We would say that 2 to the third power equals 8. That's the same thing as saying log base 2 of 8 is 3. Okay. So this one's in log form, logarithm form, and this one's in exponential form. Okay. They're both saying the same thing. Both saying the same thing. Okay. One of the big things we're going to practice in this section, we're going to practice going back and forth. Okay. So like if we have an equation in logarithm form, let's rewrite it in exponential form. If we have an equation in exponential form, let's be able to rewrite it in logarithm form. Okay. Because sometimes if you're dealing with one form, then maybe the other one would be easier to work with. You can go back and forth. Okay. So before we do that, we talked about the graphs of exponential functions last time, so let's talk about the graph of a logarithm. Okay. So our logarithm graph is going to look like this. And the y-axis is a vertical asymptote. And so that doesn't show it real good, does it? And so we have a vertical asymptote. That x equals 0, the y-axis. Okay. But the graph goes down forever. Okay, it goes down toward negative infinity at 0. And then if we look at what happens as our x values get big, okay, when you look at these graphs, they look like they go horizontal. Okay, so it'll look like maybe we've got a horizontal asymptote in there, but we actually don't. We actually don't. This thing will keep increasing. Okay, the y values will keep getting bigger forever. It really goes toward infinity. It just does it really, really slowly. Okay, it does it really, really slowly. So the graph will almost look like it goes horizontal, okay, but it doesn't actually have a horizontal asymptote. It just takes a really long time to grow. Okay. So if you remember with exponentials, we said they grow really, really fast. With logarithms, they grow really, really slowly. Okay. If we are going to do our transformations to a logarithm function, the only ones we're really going to talk about are the reflections. Now you can do the vertical and horizontal translations too, but let's think about reflections here. Okay. And if we just put a minus sign out in front of the log, remember if we just put a minus sign out in front of the whole function, it's going to switch top and the bottom. That's an x-axis reflection. X-axis. So, what's that going to look like? If we'll still have a vertical asymptote at the y-axis. Maybe if we switch the top and the bottom, then maybe that's going to look like this. That would be negative log x. Okay. And if we instead we made the x negative, that would be a y-axis reflection. So that switches the left and right. And so this is. What does that look like if we switch left and right? So we're still going to have a vertical asymptote at the y-axis, but if we switch left and right, that's something that looks like that. And then one other thing to mention about these, on our exponential functions, we had a special point. And we said the point 0, 1 was going to be on the graph of any exponential function, no matter what the base was, as long as it hasn't been shifted around. What I'm saying is the base doesn't change that point's going to be on the graph. We have a special point like that on logarithms as well, and it's the point 1, 0. That's going to be on the graph of any logarithm, no matter what the base is. Because we have log base b 1, that's going to be 0 because that's saying some number to what power gives us 1. Okay, so any number to the 0th power is going to give us 1, so that's going to be on the graph of any logarithm. Got the idea on those? All right. So with logarithms, usually we write log and then a little subscript of the base. But we've got two special cases where we don't have to write the base down. Okay. So one of those is if we were going to write log base 10. You normally don't see it written that way. Normally the way you'll see that written is just log without a number down there. So if you're missing a base, but you don't have the base written down there on the logarithm, that's implying that it's base 10. Kind of like on square root, we don't write the 2 on the radical. With logarithm, If your base is 10, you don't have to write the 10 down there. Okay. And that logarithm, base 10, is called the common logarithm. So the only reason why that one's special is because the numbers that we use day to day are base 10, right? Our digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we flip over and have a 1, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so that's the base of our everyday number system is base 10. And we have 10 digits that we use. Okay. Have I mentioned in here why we use base 10? You would think there would be like some really important reason why we don't use some other system, right? Like why do we not do everything in binary like computers do, or why 10? That's the question. What's special about 10? I got a guess? That's something that makes 10 special? It's really simple. How most people have 10 fingers makes it easy to count. That's really why, historically, why we end up using base 10 numbers for most things. Okay. All right, our other special logarithm. You remember e from last time? If we were to use a logarithm with a base of e, you don't ever see it written like that. The way you'll see it written is ln. Okay. And that means a logarithm with base e. We call e the natural exponential, so the logarithm with base e is called the natural logarithm. Okay. And it's a little weird we write ln instead of nl, to me at least, since it's called the natural logarithm. I think it goes back to the Latin. I think if you do, it's like whatever the word for logarithm is, naturalis or something like that, then it's ln instead of nl. So where we get natural log from. Okay. So if you see a logarithm without a base written, log with no number, that's a base 10. And if you see ln written, that's just a logarithm base e. Base e. Okay. We can use any number bigger than 0 as our base. You can do fractions. Okay. So let's think about some logarithms here. So a lot of times if you're trying to figure out what the number value of a log is, okay, you can use a calculator, that's fine. But there are some times when it's easier to figure out and we don't have to have a calculator. Okay. So I'm just thinking about that. It'll help us remember what logarithms are telling us. So this says 5 to some power will give us 25. We want to know what that power would be, what that exponent would be. Or what's that one going to be? Yeah, it's going to be 2, right? 5 squared gives us 25. So if we write that in exponential form, that would say 5 squared equals 25. Okay? So these two things say the same thing. These two equations say the same thing. Okay? And one way that comes in handy, so maybe like if you're trying to figure out log base 5 of 25 equals something, you can put a variable there and then change it to exponential form. To do that, we'll have 5 to the x power equals 25, and then sometimes it's easier to figure out what the power would have to be looking at it that way. So there, x would need to be 2. We want 5 squared. Okay. Let's see, let me find us a good one. What about well, we got that. Okay. And we want to we'll say express in exponential form. So we want to rewrite it as an exponential equation. Okay. So in order to write it as an exponential, we want to write the base to some power equals some number. So the first thing we need to do is we need to identify what the base is. Okay, the base is going to be the same in logarithm form and in exponential form. So on this one, the base is normally the little number written down here. But this is one of our special ones. We don't have a little number written down there. You remember what the base of this one is, the natural log? It's e, yeah, base e. So that's what we want to start with. Okay? So we're going to have e, that's our base, to whatever's on the other side of the equal sign. So we're going to have e to this power, e to the 7y power. That's weird, but it's okay. And that's going to equal whatever was inside of the logarithm. So equals 3. Bless you. Oh, let's do another one. Same thing, we're going to start out with a logarithm and rewrite it as an exponential. So okay. There's a logarithm equation. We change that to exponential form. Start with the base. So I wrote it on this one. We didn't have to, but I wrote 10 down there. So we got log base 10 to what power? Third, yeah. Third power, and that equals yeah, we're just rewriting, yeah. Yep, just writing in different form, that's right. So that's going from logarithm form to exponential form. Okay. We'll do maybe like one more of these, and then we'll do some other direction. Okay. Let's do one more. Let's do there's that one. We want to rewrite it in exponential form. Start with the base. So we'll have our base is 3. That's going to be our big number. And what's our exponent going to be? X. And that will equal 9. That's all we have to do on those. We're not trying to solve for anything. We're just rewriting. Okay. Let's do some other direction. Start with exponentials and go back to logarithms. Okay. So 10 to the third power equals y. So if we're trying to put this in logarithm form, we're going to have log. And then whatever our big number is, that's going to be our base. So this one's going to be base 10. And then what goes in as the argument inside the log. Not 3 on this, and this one's going to be y, and then that's going to equal the 3. Since this one's base 10, we could also just write log. Okay. Either one of those is okay. Since that's the common logarithm, you don't have to write the base. So there's a change there. And let's do no. We want to change this to logarithm form. What's the base of our logarithm going to be on this one? 3, yep. It's the same as the base of the exponential, so we're going to have log base 3 of 70 equals x. Yeah. Okay. And if you're not real confident, ignore the first part and think about if you were going to change it back the other way. Okay, for sometimes one way will make more sense to some people than the other way. So to me, going from log to exponential seems like clicks a little bit better. So I can say, okay, this is 3 to the x power equals 70, and that's what I had. So right, so there's our transformation there. Okay. Questions on doing those? Okay. Okay. So something else to mention here, and we've talked about inverse functions. So if we've got log with some base of x, that is the inverse function of b to the x power. Okay. So it can be a little confusing the way I've gotten that written down. Okay. It works in reverse too, right? If one function is the inverse of another, you can use it backward as well. Okay. So you could say b to the x is the inverse of log base b of x. Okay. So let's remember what inverses do. They just undo each other. Right? They cancel each other out. Like multiplying by 2, dividing by 2, that's an inverse operation. Right? So here's what I'm saying. Like we've got log base 5 of 5 squared. So we got an exponential inside of our logarithm. The thing that you have to look out for, okay, is you want the bases to match. The bases have to match in order for them to be inverses. So the base on the logarithm and the base on the exponential have to match. If they do, they cancel each other out. Okay. So here, log base 5 of 5 some power, the log base 5 and the exponential base 5 are going to cancel each other out. Okay. And this thing is just going to give us 2. That would be our value of log base 5 of 5 squared. It would be 2. because the bases match, so they cancel each other out. And we could do it the other way around. We do it the other way around. We could say, this one looks weirder. Okay? We could say 5 to the log base 5, 2. So this is like a base. Let me write it real big. Okay? And the log's up there in the exponent. So you don't run into that as much. Okay? It looks weird. But in that case, the exponential base 5 and the log base 5 would cancel each other out, and that would still be 2. Because of that, okay, something else nice happens that makes some of these logarithm expressions really easy to simplify. We'd have a situation like this, where we got log base 3 of 3. What's that going to equal? The base of the logarithm and the base of the number inside the logarithm are the same. So they're going to cancel each other out, and it's just going to leave us with the exponent that we've got. On this one, our exponent is just a 1. So anytime you have log base some number of that number, well, you're going to get 1. Okay. So anytime the base of the log matches the number you've got inside the logarithm, that simplifies to just 1. It says 3 to the first power equals 3. That's true. Okay. Something else that helps us simplify sometimes, if we've got a log with any base of 1, we kind of already mentioned this one, but what's that going to equal? It says b, so some number to some power equals 1. What power do we raise something to get 1? So 5 to what power will give us 1, or 17 to what power will give us 1? Be 0. Be 0. Okay. So that in exponential form, that's saying b to the 0th power equals 1. Okay. So anytime you've got a 1 inside of a logarithm, it doesn't matter what the base is, that's going to simplify to 0. Okay. It's going to be 0. You don't have to think anymore about it. Okay. And then thinking about our two special cases of logarithms, it's not quite so obvious. Well, if we've got the common log of 10, so we don't have the base written, so that means the base of our log is 10. And when the base of the log matches the number that's inside there, it's just 1. And then with our other special one, natural log, again, it's a little easy to forget, but the base of the natural log is e. So if we have ln of e, the base of the natural log and then the e that's inside the natural log match, that's going to be 1. So let's think about some of these. Sometimes these are really straightforward. Sometimes we have to think a little bit. And sometimes they'll write the parentheses, sometimes they won't. So I'll write them sometimes so we can see. It says evaluate the expression. That means we should get some kind of answer. We should simplify this thing out, some kind of answer. What's that one going to be? We got log base 9 of 9 to the 13th power. The bases match, right? So those are going to cancel out. What are we going to be left with? 13. 13. Okay. Okay. How about this one? Got the natural log of 1. What's that going to be? Don't let the fact that it's natural log bother you. Any logarithm of 1, remember what it's going to be? It's going to be 0. As it says, the base to what power gives us 1? The base to 0th power will give us 1. Okay. Okay. Looking at one's a little bit more work. What about this one? Not quite so obvious. One way of thinking about it is that we're saying 5 to what power gives us 125. Might be able to figure it out that way. Okay. Something to look for is that if we can get the base of whatever's inside the logarithm, the base of the argument, to match the base of the logarithm, then they'll cancel out. So a couple of ways of thinking about this one, but 125 is 5 to the 3rd power, right? 5 times 5 times 5. So one way of thinking about this one is like this. So now what's that going to be? The bases match now, so it's going to be 3. 3. Okay. And thinking about another one, we haven't done one quite like this yet. Also got like log base 7 of 1/7. And 7 what power gives us the fraction 1/7. Okay. So remember, that's like 7 to the 1st power. So we could rewrite this. And it's not super obvious to do this if you haven't seen one before, but we could change that to 7 to the -1 power. Right? That's the same thing as 1/7. So from there, though, it's going to be -1. -1. Okay. think that's about it on this section. You got several problems. Let's see how many have I got in this assignment. I got 15 in there, and some of them got multiple parts, but a lot of them are really short. Okay? A lot of them are just rewriting. Okay, that's the main takeaway I want you to have in this section, is to be able to rewrite from logarithm to exponential or exponential to logarithm. That's what most of the problems are. It looks like a lot, but they're pretty short. They're pretty short. Okay. Try to work on this before Tuesday. Okay. Because we don't want this part still hanging over us when we get to the stuff we need to do Tuesday. Okay. So, it'd be a little bit more involved than this one. This one's not too bad, but yeah. Okay. All right.